Good morning, physics. Today is Friday, end of week 8, I think. I don't know anymore. Life has lost all sense of time, as I'm sure it has for you. So what we're going to be doing today is we're going to be talking about wind instruments, and with this, and sort of like the idea of how these various YouTubers have sort of created some interesting music using household items, and sort of like why when they use these instruments, why it sort of creates these different pitches based on our knowledge of waves so far. So to start us off, one of the things that sort of goes on is wind instruments. So with these wind instruments, and sort of the main idea is that you have what would be a vibrating column of air. So as in, like, you just have this area inside of something where it can vibrate. Now, there are two possibilities. There's one where you have it closed at one end, and one where you have it open at both ends. The reason why we don't have something where it's closed at both ends is because the sound doesn't really do a good job of propagating if it doesn't have anywhere to go within. Basically what happens is the air inside here vibrates and then it's released into the rest of the environment. If it doesn't have the ability to go anywhere, it's unlikely for it to produce much sound. You can try and test this by sort of, if you have like some sort of tube or anything, closing both ends and tapping it against something, you'll notice it won't make much of a sound. However, if you have one of those ends uncovered and you tap it against something, it'll make more of a sound with a clear pitch. So with this, there is sort of things that go on. When this happens, there's only a certain amount of a wave that is able to fit into these vibrating columns. And so basically you have your length of your columns, and those sort of determine what the wavelength is. So if you have closed on one end, what ends up happening is you end up having a node here, if we think of it in terms of standing waves, and then it only is able to sort of reach the peak or the trough out here, even though I'm doing a really terrible job drawing this. So what you end up having is your length of your pipe is only equal to 1/4 your wavelength, your lambda. So this would be 1/4 lambda. So if you were trying to create a specific note, if you knew the wavelength of the note you're trying to hit, you would make a tube that would be 1/4 the length of the note. However, when you have a open-ended tube, what sort of can end up happening is you end up are able to have like a node right in the middle, and you go peak, peak, or you can have two nodes at either end, and so you have the antinode in between, but you end up with the length is actually equal to 1/2 lambda. So basically the difference here is this would be 1 octave lower. For those of you that know music, an octave is sort of, we have various number of octaves, but we have letters A through G that exist within each octave. And for any octave below or above, it's sort of a multiplying factor. So if you want to go one octave lower, if you increase the wavelength of your sounds by twice the size, you end up with a 1 octave below. If you end up having the size of your wavelengths, you end up with 1 octave above. So the one on the left is 1 octave lower than this one. And so basically the idea here is, if you think of sounds, the smaller wavelength you have, the higher the frequency, and therefore the higher the pitch. However, in the reverse sense, the longer the wavelength you're using, the lower the frequency is, and therefore the lower the pitch is. So sort of using this idea, and also the idea that with strings, if you have a string, and it vibrates, it basically depends. You have different speeds of sounds in strings. It's not just the speed of sound in air, it has a lot to do with the speed of sound in the string, and that part can be a little harder to figure out if you ever were making stringed instruments. But there are equations out there to sort of calculate it based on the tension and the mass of the string and all that. But with strings, they have various number of wavelengths. So they can have, so the harmonics of string so if we assume the string is length L, what can sort of happen, depending on how fast waves can travel in it, you can produce lambda can equal which is L over N. Excuse me. Oh, God. Which is the length of the string divided by the number of, like, the harmonic order. So you could have lambda, 2L over N. So in the first one, first harmonic, you just have two nodes and one antinode, so it's vibrating up and down. You would have a lambda of 2 times the length of the string. If you were able to increase the tension or something along those lines, you might be able to, or apply more energy as you strum it. You might be able to go higher than that, but for the most part, strings themselves have a wavelength of 2L over, lambda is equal to 2 times the length of the string. But what sort of happens here is based on the properties of the string and the tension in it, you might end up having different speeds of sound in the string itself, which causes different frequencies to be produced. So that's one key thing to sort of keep in mind. And let's see. Beyond that, there's a few different videos we can see. So to sort of demonstrate this, I have a TikTok artist channel pulled up. And so you can sort of see sort of an example of it. As you see here, he has glasses filled with different amounts of water. And each one produces a different sound based on the amount of water filled and the amount of air available to vibrate. So it's one of those sort of like generally cool things that sort of goes on, is he's created his own instruments, sort of using the properties I just talked about by filling glasses up with different amounts of water to create different frequencies and wavelengths. So this time I'll just not talk and just let you see it. All right, and I think that's enough. So the idea here is you're going to look at, you can find your own artist. I posted a few different links, and there'll be a couple links attached to the assignment itself of artists that you can look at and sort of listen to. And just what I want you to do is to write about a paragraph to try and explain how one, if not all, of their instruments work. And so that's the plan for today, and I hope you all enjoy it. Have a good one.